In this video, I'm going to introduce you VLAN and trunking. Let's look at a simple network topology. In this topology, we have 4 PCs connect to 3 switches. The 4 PCs are in network 192.168.1.0 network. They have IP address .10, .11, .12, and .13. When PC1 sends out the broadcast traffic to 192.168.1.255, it gets a reply from PC2, PC3, and PC4 on IP address .11, .12, and .13. In another topology, we create VLANs. Users are grouped according to their job function. There's a VLAN 2 for IT department, VLAN 3 for HR department. The 2 PCs in IT department belong to network 192.168.1.0. The 2 PCs in HR department belong to network 192.168.2.0 network. When we create VLAN, we create separate broadcast domain. When PC in VLAN 2 send out the broadcast traffic, the traffic will only be received by PC on the same VLAN. PC on VLAN 3 won't receive the broadcast traffic. VLANs allow network administrator to segment networks based on the factors such as a function, team, or application, regardless of physical location of the users and the devices. Each VLAN is considered a separate broadcast domain. It is a logical or separate network. Devices within a VLAN act as if they are in their own independent network, even they share a common infrastructure with other VLANs. VLAN create a smaller broadcast domain. It reduces unnecessary traffic on the network. So VLAN improve network performance. Devices on different VLAN cannot communicate with each other without the services of Layer 3 device. So VLAN improve network security and make the network management efficient. There are different types of VLAN. Default VLAN is a VLAN 1. By default, all switch interfaces belong to VLAN 1. We cannot delete or rename VLAN 1. Data VLAN is used to carry user-generated traffic like email or web traffic. Native VLAN is VLAN 1 by default. Native VLAN is used to carry untagged traffic. We look at this topology. There are VLAN 1, VLAN 2, and VLAN 3. The connection between switches need carry traffic for VLAN 1 and VLAN 2 and VLAN 3. So this connection need be set up as a trunk link. When traffic goes through the trunk link, they will be tagged with the VLAN information. But when we have legacy device like a hub connect to the network, hub has no idea about VLAN. So the traffic sent through hub is sent through the native VLAN. So the native VLAN is used to carry untagged traffic, meaning there's no VLAN ID, no VLAN information. Default native VLAN is VLAN 1, but we can change the native VLAN to other VLAN. So when we change the native VLAN on one side of the connection, we need to change the native VLAN on the other side of connection as well. Otherwise, we will receive native VLAN mismatch information. A management VLAN is a data VLAN configured specifically for network management traffic, including SSH, Telnet, HTTP, and SNMP. When we configure IP address for a Layer 2 switch, we configure IP address on the management VLAN. So by default, VLAN 1 is a management VLAN as well. Voice VLAN is used to carry voice traffic because voice traffic has a different requirement for bandwidth and delay. In this topology, the connection between switch 1, switch 2, and switch 1 and switch 3 need carry traffic for VLAN 10, VLAN 20, and VLAN 30. The link need to be set up as a trunk link. A trunk link is a point-to-point link between two network devices. It is used to carry traffic for more than one VLAN. The traffic connect to PC only carry traffic for one VLAN, so those interface is known as an access port. So interface F011, F018, F06, even on other side of the connection, they only carry traffic for single VLAN. They are access port. But the connection between two switches need to be set up as a trunk link to carry traffic for more than one VLAN. There are different trunking protocols. IEEE has 802.1q as a trunking protocol. 802.1q insert VLAN ID in the Ethernet frame. After we insert VLAN ID, we need to recalculate the FCS. So the VLAN tag has information for VLAN ID. So VLAN ID field is a 12 bits. That is why we can have up to 4096 VLAN. The VLAN ID starts from 0 up to 4095. DTP Dynamic Trunking Protocol is a Cisco proprietary protocol that lets the Cisco switches automatically negotiate about the trunk mode. When we configure the interface in the interface configuration mode, we can configure the interface with the switch port mode, dynamic auto or dynamic desirable. That will enable the DTP negotiation. The dynamic auto means the interface is capable to be a trunk link, but it relies on the other side of the link to decide it ends up as a trunk link or access port. Dynamic desirable is the same. Dynamic desirable means the interface is capable to become a trunk link. It also willing to become a trunk link. So when we have both sides as a dynamic auto, the interface is going to end up as a trunk link. Even we have one side as dynamic auto, another side as dynamic desirable, the interface will end up as a trunk link. But if you have both sides as a dynamic auto, the interface is going to end up as an access port. So the access port is an interface carry traffic for a single VLAN, and the interface can be configured as a permanent trunk mode. When we configure switch port mode trunk, the trunk can carry traffic for multiple VLAN. We can disable DTP by configure switch port non-negotiate. That will stop the DTP negotiation. So let's do some demonstration to look at how we can configure VLAN and the trunk. So I built the two simple network topology. We already see the first one. When PC1 sends traffic to the broadcast IP address 192.168.1.255, it gets reply from PC2, PC3, and PC4. Now we are going to set up the separate network by create VLANs, and then we assign the interface to a different VLAN. So I'm going to start from the first switch, switch 1, and go to switch 1 configuration mode, give a host name switch 1. Then before we configure VLAN, we can use show VLAN brief to verify the default VLAN set up on the switch. When we use the show VLAN brief, we can see VLAN 1, VLAN 1002 up to 1005 already be created. all interface on the switch at the moment belong to VLAN 1 because VLAN 1 is a default VLAN. Then we can create more VLAN by using VLAN followed by VLAN ID. See, for example, I'm going to create VLAN 2. Then we can give a name. We call it IT. Then we can create another VLAN. We call it VLAN 3. We name it as HR. So now we use the show VLAN brief again to verify our configuration. Now we see VLAN 2 and VLAN 3 be created in the VLAN database. After we create VLAN, VLAN information will add to the VLAN database. We can use a show flash to check the VLAN database. You can see VLAN.dat now exists in the flash. It's used to hold the VLAN information for VLAN 2 and VLAN 3. After we create VLAN, we can remove the VLAN by adding no in front of the VLAN ID. I say no VLAN 2 and no VLAN 3. But what will happen if we try to remove VLAN 1 by no VLAN 1? So you see we receive a message, the default VLAN 1 may not be deleted. So let's check the VLAN database. I use do show VLAN brief in current mode. You can see VLAN 1 is still there, but VLAN 2 and VLAN 3 be deleted. So we add VLAN 2, name IT, VLAN 3, name HR back. Now, after we create VLAN, we need to assign the interface to separate VLAN. So in this topology, I have interface F06 belong to VLAN 2, interface F011 belong to VLAN 3. So let's do that. So we go to interface F06. We configure the interface as an access mode because the access mode can only carry traffic for single VLAN. We do switch port mode access, switch port access VLAN 2. Then we do the same thing for interface F011. We do switch port mode access and switch port access for VLAN 3. Now let's check our VLAN database again. We do show VLAN brief. You can see we have VLAN 2, VLAN 3. Now interface F06 belong to VLAN 2, interface F011 belong to VLAN 3. So far we create VLAN, we assign the VLAN membership, the interface be assigned to the VLANs. Now we have interface F01 at the moment belong to default VLAN. Interface F01 is an interface connect to a switch 2. So we need to set up as a trunk to carry traffic for VLAN 2 and VLAN 3. So the interface when carry traffic for more than one VLAN, it need be set up as a trunk link. So configure T interface F01 switch port mode trunk. We set up as a trunk link. We can use show int show interface trunk to check our configuration. Now interface F01 is on, it's set up as a trunk mode. When we verify the trunk link, interface F01, the mode at the moment is on because we configure the switch port mode trunk. The encapsulation is a DOT1Q, that the trunking protocol will enable the trunk to insert VLAN ID for the traffic. So at the moment, interface F01 is in trunking mode. A default VLAN is a native VLAN is a VLAN 1. all VLANs are allowed on interface F01. That is by default. At the moment, we have VLAN 1, VLAN 2, and VLAN 3. They are active in the management domain. Now we need to do the same on switch 2. On switch 2, I'm going to configure, change the host name to switch 2. Then we are going to create VLAN 2. We give a name IT. VLAN 3, we give a name as HR. Because there's no end device connect to switch 2, so we don't need to assign the VLAN membership. But interface F01 connect to switch 1 need to be set up as a trunk link. So we do switch port mode trunk. Then we use the show int interface trunk to check our trunk. So F01 is in trunking mode. The native VLAN is a VLAN 1. Now on switch 3, I'm going to do the same. Switch hostname switch 3. We do VLAN 2, VLAN 3. So what will happen if we didn't give name to the VLAN? We can use show VLAN brief. So we can see the operating system assign a default name to VLAN. So VLAN 2 is known as VLAN 002, VLAN 3 is known as VLAN 0003. So config T, now we can go to VLAN configuration mode. When we type VLAN 2, we are in VLAN configuration mode. We can give it a name now. We call it IT, VLAN 3. We call it as HR. So we have PC connect to switch 3. We need to assign the VLAN membership. So interface F06 switch port mode access, because it's only configure or it's only carry traffic for single VLAN, and switch port access, that is for VLAN 2. And interface F011 switch port mode access, switch port access for VLAN 3. Now on both switch, we already assigned the VLAN membership. We can check the interface. They belong to different VLANs. Then on switch 1, we haven't set up the trunk link, right? So on switch 3, now we need to set up the trunk link F01 switch port mode trunk. We set up it as a trunk link. Now we have VLAN created. We assign the VLAN membership. We create the trunk. Now let's see if from PC1 for the IT department, if I want to send the traffic to a broadcast network, who is going to receive it? So I go to PC and I go to the desktop, and I can check the PC already be configured with IP address. Now I'm going to ping 192.168.1.255. So I ping the broadcast address. So this time, we should only have reply from ITPC2 because they are on the same IP network. Let me check the PC2's IP address. The reason for that, you can see the light is still in orange, it's not ready. So I'll just do this. What I did configure interface F01 as a trunk on switch 2, but I didn't configure interface F02 as a trunk. So let's see if I do show int trunk and interface F02, because by default the interface mode is dynamic auto. So F02 left with dynamic auto. And when we configure switch 3, we set up the interface as a trunk. So these two ends, they are going to negotiate about the trunk link. Switch 2 F02 is dynamic auto. Switch 3 F01 is set up as a trunk link. After negotiate, it ends up as a trunk link. So the encapsulation is DOT1Q because we have negotiation. They negotiate about the trunking protocol. So even F02, we didn't configure it mode as a trunk, but after negotiation, the interface ends up as a trunk link. So go back to our PC this time and we check the ping. So you can see when I ping from PC in IT department, I only get reply from PC on 192.168.1.11 because .1.11 it belongs to VLAN 2. By create VLAN, we separate the broadcast traffic. Now we can verify on HRPC on on the second PC. If I want to ping 192.168.2.255, we see which device is going to reply. So we got reply from 2.11. So 2.11 is PC in VLAN 3 belong to the HR department. So when we create VLAN, we separate the broadcast traffic and we can improve the network performance and also provide the security. Now, I just want to show you more configuration about the trunking. So at the moment, we configure interface F01 as a trunk. So the trunk native VLAN is a VLAN 1. Let's create another VLAN. Config T, I'm going to create VLAN 99 and the name, I call this one as a native VLAN. So I'm going to use VLAN 99 as a native VLAN. Because the VLAN 1 by default is a default VLAN, management VLAN, also native VLAN. For security reasons, we should change the native VLAN to other VLAN than VLAN 1. In this demonstration, I'm going to use VLAN 99. So I'm going to configure interface F01 switch trunk native. So this time I specify the native VLAN 99. So to change the native VLAN, I go to the interface configuration mode to switch port native VLAN 99. Now let's check our trunk, show int trunk. You can see the native VLAN changed to 99. Let's check switch 2. On switch 2, we receive a message. It tells us the interface. So it receives the BPDU with inconsistent peer VLAN ID 99. The interface is blocked because it's inconsistent local VLAN. There's a native VLAN mismatch. The reason we receive this message because we changed the native VLAN on switch 1 to VLAN 99. On switch 2, the native VLAN is still VLAN 1. So we go to interface F01. We configure with the switch port trunk native VLAN 99. Then you say we haven't created VLAN 99. So what's happened after I configure with switch port native VLAN 99? And we receive a message say it's unblocking this interface because the port consistency is restored. Let's check VLAN database. I do show VLAN brief and we haven't created the VLAN 99, so I do VLAN 99. Now show int trunk. You can see VLAN 1. So interface F01 now has a native VLAN 99 and the other interface connect to switch 3 still have native VLAN as a VLAN 1. If we want to change native VLAN on the link between switch 2 and switch 3, so we need to go to interface on each switch and to reconfigure it. Another thing I want to have your attention is about the allowed VLAN link. So when we create VLAN, we create a trunk. by default, all VLAN is allowed on the trunk link. For security reasons, we should specify which VLAN is allowed on the trunk link. So on switch 2, I go to my trunk link interface F01 and switch port trunk. We can configure allowed. So if I put a question mark, we can see there's an allowed VLAN ID. I'm going to allow VLAN 2, 3, and 99 because at the moment I only set up VLAN 2, VLAN 3, and VLAN 99. So go look at the trunk link, show INT trunk again. Now interface F01 only allow VLAN 2, VLAN 3, and VLAN 99. So what will happen if I create another VLAN and I want to add it to the trunk link? Say for example, I'm going to create VLAN 4 and then we want allow VLAN 4 on the trunk link. I do interface F01. If I do switch port trunk allowed VLAN. So if I simply specify allow VLAN 4, let's see what will happen. Do show INT trunk. Now it only VLAN 4 allowed on the trunk link. That is not what we want. So when you want to add a new VLAN to the allowed VLAN list, we need to say allowed VLAN. So we put the question mark. We can use add. So we need to add VLAN 4. Instead of to just say allow VLAN 4, we need to add VLAN 4. Then VLAN 2, 3, and VLAN 99 will be reserved. So another way to configure, I just reconfigure the allow VLAN list. I do VLAN 2, 3, 4. I can do 2 to 4 plus 99. So do show INT trunk again to check the trunk configuration. Now VLAN 2, 4, and 99, they are all allowed. Now we did set up the interface F01 at the trunk. On interface F02 on switch 2, I want to configure with a DTP to negotiate about the trunk link. So at the moment, they all set up as a trunk link, INT trunk. So on switch 2, it has dynamic auto. Now I'm going to change it to interface F02. I will put it a switch port dynamic switch port trunk. So the command we need to do is a switch port mode dynamic dynamic. I can configure with a dynamic desirable or dynamic auto because by default it's already dynamic auto. I'm going to do the dynamic desirable. Now after we change the mode, we can use show INT trunk to check it. So the mode is changed to a dynamic desirable and it end up as a trunk mode. And another thing I want to show you is the show command, show switch port, show interface F02 switch port. So from the show interface switch port, we can see this interface is a layer 2 interface. It's configured with a dynamic desirable. It actually operational mode is a trunk because other side is trunk. After negotiate, and mode is become as a trunk link. So when it's a trunk, the encapsulation is DOT1Q. It uses 802.1Q trunking protocol. And we have this interface is configured as a trunk VLAN. It's still VLAN 1 because we haven't changed the native VLAN on F02. So if we check the interface F01, you will see a native VLAN is changed to VLAN 99. So at the moment, the trunk is allowed for VLAN 2 to 4 and VLAN 99, but F02, because we didn't change it, and by default, it allows all VLAN. So that is what I want to share with you today. We did look at what is a VLAN, how to create VLAN, and how to create trunk and trunking protocol. Thank you for watching.